Today, I'm going to be using the Shopsmith 520 to turn some spindles. There's going to be 8 of them. Spindles are 13 7/8 inches long as a blank. When turned, they'll be 12 7/8. The template is made out of plywood. It's concentric. The left end and the right end are similar, as close as I could make them. Okay. Going to be using a lathe follower or a lathe duplicator. So how about if I set you up here on a time lapse and we'll capture that process. Okay, that spindle that's in there has already been cut down to 8 sides. I take the corners off of it with the table saw. So the first mission I have then is to turn it into a cylinder. Now I covered this on a previous video, so some of this will be a little bit redundant, but it is a different type of spindle. It's longer, and you'll notice that at this point I'm cutting the coves in it. The coves are the easiest to cut, and they require the most amount of material to be hogged out of it. So I'll spend a little bit of time on them, and then I'll come down and start working on the beads. Those little V's that are there in the beads, you start down in the bottom of the V, and then you work your way up toward the top, round it over. It just seems with this lathe duplicator that you can get a better bead. You can follow that curve a lot better wiping that follower up than you can trying to dive down and follow it on your way down. But at any rate, just keep working it down. It's like, you know, the old saying about eating an elephant one bite at a time, is you just kind of get it rough. Now my goal at this point is to get it down to where that lathe follower has about 1/16 of an inch of space or so between it and the pattern that is following. The reason why is because you want to take your final pass pretty much as a nice, long, smooth, even pass so that everything blends together well. So I'll just work it down. You'll notice that every time I go through there, it starts resembling the edge of that pattern just a little bit more. And I'll start to take a little bit longer strokes with it, trying to keep it smoother and smoother. I'm not trying to hog as much material out at this point. Once I get that down, get it so that it's smooth and follows that, then I'll go into sanding. I use 4 different grits of material and sand it down from a 150 all the way to a 400. I used to go to 600, but what I found is that if you sand them that smooth, when you go to put finish in it, and I'll be covering finish later, you don't really get a good penetration with the oil. And you want a penetration because this is walnut and you really want to bring out all the grain. Okay, but I'll work my way down in successive grits until I get it to where it's basically smooth, so there's no lathe marks left on it, so that all the transitions match up pretty good from one direction to the other, from when you're going rising up, going around a curve, or diving down into a cove. You really want that to blend, because any little mark that you have on there will show up whenever you finish it. But at any rate, after sanding, the only thing left to do then is to put the finished size on the tenons on the end. The rim of the stock is made out of black walnut material. I'm not going to illustrate all the steps, but it's planed to 1.5 inches thick, then it's ripped to 4 inches wide. It's cut on a miter saw at 22.5 degrees. Then it's taken to the table saw, and a dado blade is used to cut a 7/16 inch thick by 1.5 inch deep dado in each one to join them together. The finished dimensions of the wheel are going to need to be 29.5 by 32.5.
Okay, here's an overview of this drilling setup. This is a stop for depth. This is the end stop for the part, so that it's always located the hole's always located exactly in the center. The height is set by the distance between the table and the center of the drill bit. The fence keeps the part perpendicular and the same distance from the drill bit all the time. This is a safety put on here to stop the fence from wandering, because there's a lot of pressure whenever you're drilling. The dust collector doesn't really work well in this, but I set it up anywhere so that it's coming in to the operation. And over here, the machine is set up so that it will only drill as deep as the stop will allow it to drill, so they don't drill a hole through my fence. And the speed set is D, and D works out to 1,050 RPMs. That's the speed you're supposed to use when drilling wood with a 9/16 inch bit. Okay, so I have this piece of wood here. I think it's going to have some pretty good grain in it. Walnut. That looks pretty good. It's got some fire grain coming out of an... Got a little bark inclusion here, but I'll cut that out. Got a little knot coming up here. It comes out on the end down here, so I'll trim right along this edge right here, and right along here, That'll get rid of the bark inclusion. And I think that'll make a nice hub for the wheel. So the hole it drills will be 3/4 of an inch deep.
In about 1980, barn wood was really hot for making picture frames, putting up wainscoting, that sort of thing. And my brother found an old barn. We went out to tear it down. On the inside of the lintel over the main door was a date 1872. As we started tearing it down, I discovered that the floor of the loft and many of the rafters that were supporting it were made out of black walnut. I use it for special projects. Have just a little bit of it left. One of those pieces is the hub for this wheel.